Good afternoon. It's a pleasure to inform you about our PLM project we're running at Stadler. We decided about a year ago, last summer, to upgrade our environment with a 3D experience solution supported and implemented by Technia Transcat. So that's the reason why I'm here. But first, short something to Stadler. Probably not everybody from you have been driving in a train from us, but we do our best you can do that in the future. So we are growing and delivering locally trains to Scandinavian areas, but as well to other European areas. Stadler itself is a split company into different divisions. We come out of Switzerland. We have our main quarter there, and we still have over 3,000 employees in Switzerland. The rest is growing, Germany a little bit, then Central Europe, and the service department. Service brings us to everywhere in the world. As we deliver trains, some of our customers want them to be maintained by us, and then of course we build new subsidiaries. So we have even a local subsidiary here in Sweden to maintain MTR Express trains. Stadler itself has grown from almost nothing, you heard it, throughout the last 20 years, 25 years. We are more than 7,000 employees in the meantime. We did that mainly through internal growth, but also by a few acquisitions. If we look at the turnover, we are in the meantime over 2 billion Swiss francs turnover, and had just an order entry last year of about 4 billions. So there is potential room to grow further, and I think this makes the company exciting, but brings some challenges. Before we look at that, there are different types of trains. We heard this morning subways, or taxis. What is better to be? We are clearly on railways and equipment which runs on tracks, from LRV, smaller commuter driven trains to the bigger and the more higher capacity trains which bring passengers from cities to cities, or at least into the city centers and other locations. As you see, we have a wide variety of different trains. We sold more than 7,000 trains throughout our time, which is quite amazing. Gives us also a chance to grow with service, renovation of these existing trains, and modifying. By looking at these few product lines we do have, it seems rather easy to keep that aligned and synchronized. It's not that easy. Even we have 1,400 flirts sold. Average project size is about 10 trains. And then you not only change the color or the seat, you really do everything differently. We talk about that in a few minutes. But this means we highly customized. We really listen to our customer, and we try to provide a small company which needs 1 or 2 trains as well, the best possible solution as a bigger operator like NSB in Norway, which has close to 100 trains now from us operating, and they still have to stay the same or stick together. Now, what brought us to PLM approach? Probably other companies are stuck in these challenges as well. We have short product cycles or development cycles, means negotiations rather take long. Finally, a lot of train purchases are financed by governments or local authorities, areas, and until they decide the right politicians are in place or gone, this takes some while. And then you have to deliver something within their period of time so they can present something before the next election states. And to do so, we have to keep our timelines. This means we work in parallel still on engineering, purchasing already material, and even welding, gluing some stuff already on the shop floor. So we have a highly overlapping setting, which is difficult to achieve when you have not the right tools in place. The second one is we get more and more regulation bodies which want to see paper, even we are in a digital world. They want to, or at least get the digital twin of a lot of documents, so those things have to be coped, handled. We have sometimes documents or requirements for new projects, which just the customer itself has more than 10,000 points which he wants to be fulfilled and proven with drawing, with huge calculations, maybe just with one sentence or a visit where he can see something. And this has to be coordinated, maintained. We heard before, we are out of Switzerland. The Swiss franc, unfortunately, is not in our favor. When we export, what we do heavily, we not get that much as we did about 5 years ago. And this challenges us, as when we not earn, we are not able to invest. And so we had to look for something. I talked about the differences on the projects. Taking a Flirt, this 1,400 units we sold, we have them with 2.80 m coach wide. We have them with 2.84 m. Here in Scandinavia with MTR or NSB, they have about 3.20 m wide coach, but they are round as they have less size on the bottom and on the top. In Finland, it's about 3.20 m straight, and if you go to Russia, it's 3.50 m. You have one door, two doors, one toilet, two toilets. You have a kitchen in the train or not. You have first, second class, maybe even a prime class like they do in Eastern Europe at some areas. So you have a lot of variety, and this on the mechanical side as well as on the electrical side. And this brought us together that we wanted to bring these different technologies closer, electrical as well as the mechanical side, and really use our productive advantage with a good system that replaces some of our famous Excel solutions. And Stadler wouldn't have been able to grow without Excel, but you see on the right-hand side, the engineering side, they use the TAV5 Smart Team and Roland as an electrical CAD system to engineer their tasks. On the lower left-hand side, we have the ERP. Those are the guys which have then to order what the engineering tells them they should order, and finally coordinate the production that they are able to assemble everything together as it is planned. And between those two islands, we have a lot of manual processes like initiating orders, what material we have to order. Even we have not engineered it yet, but we know we need that amount of aluminium or a lot of other things. And keeping control of changes, also fulfilling documentation purposes is difficult in such a landscape. So we discussed and tried to align processes, what we want to do and work with. And it came out that this alignment is good if you have from requirements to engineering to production, everything aligned, and keep a track on what you do and what is the configuration. But it doesn't work completely out. We really had to see that the centerpiece of our whole alignment has to be the change management and the configuration management, as this is really something which starts initially and leads to the end. And that might sound easier as it is. The ones which have to try to develop such system and know that's quite a challenge to get that all aligned, especially as you have different departments, you have different tools and solutions in place. And we finally decided we want to go with a PLM approach. We heard it is about 20 years old technology, so nothing new which we invent here. But we want to go that way. We want to use it. We want to collaborate. You saw the growth. Before it was easy. We had more or less all our stuff at one office and you could talk to each other. It's not that easy if you talk from Spain to Minsk or from Germany to Switzerland. Maybe that is easier as you talk the same language, but still you have to exchange data and collaborate and see what these other guys are doing in your project. And this is something which we strongly believe we will achieve, and we already achieved partially with 3D experience. Protecting intellectual property. We heard before you should invite everybody in. Still we have some core things which we want to protect, and this is something which we have to do as when you get a new project rewarded, you of course can build up your own stuff, but you also need externals which help you with the engineering capacity, and they shouldn't see everything, especially as they also work for other companies, and at the end of the day it's good if you see a copy of your train, but you shouldn't get the know-how out of your system. It's okay if they photograph it somewhere and then try to reprint it or whatever to get something similar out. The next thing was fast data access. We have currently, when having just one train car we want to load in CATIA, we wait about 20 to 30 minutes until this is on the screen. So I really can test or see what I'm doing and what impacts what. And by waiting that long, you waste a lot of time. And if you load the wrong thing or want to reload something, that's a difficult thing with CATIA V5. So one of the big buy-in was that with CATIA V6, we get different possibilities in using the system and enabling that. And by now, we are about down to 1 minute, 1 minute 30 to load such a structure, which consists out of some 10, 15, 20,000 parts. And we see chances to even bring that down further. And for the management, the buy-in was that we want to enable 10% efficiency increase by various small steps, which we do daily, that bind some resources, but not in a smart way. One was the loading example, but if you assign a color, as an engineer, have to do that on the drawing, create an article which finally is able to be ordered, that it's annoying. That's not really what is sexy. You have your 3D piece and that works, and if you have to do, you do a drawing of it. That's sufficient. The rest should do the guys which finally take your stuff and use it in the project. And this is what we separated, besides a lot of other things, to get such enhancements in. And by doing that, we agreed that we join the mechanical and the electrical world partially. And to do that, we decided, besides enabling a PLM, upgrading CATIA version, also to bring in a new electrical CAD system. So when you look at the landscape in yellow marked here, we more or less radically change everything we have in place, which generates data today. This is a big step. We are grown, we have a lot of young people, and we decided that's the best way to do it. Instead of trying to do it in pieces over centuries, we said we have to do that way and benefit from it. And I will go a little more detailed into this mechanical, electrical alignment, why that helps and where the challenges lies. Today we have a mechanical view, taking a lamp belt in a ceiling, something which has to be mounted in every train, at the driver's cabin and everywhere. And on the mechanical view, they place this lamp belt in the ceiling, it's clear. They make it fit and finally create a few drawings so the guys in the production are able to assemble that. Now the electrical has a different view at this lamp belt, as he has some requirements regarding what luminization you have to provide, what voltage you have in your train, maybe the supplier or the customer wants some specific lamp type, as he already has that on stock, or some fancy LED thing which you can play around, and that you get that in and aligned. We have different worlds. The mechanical talk about the ceiling, the electrical talk about the lighting. So we have the same not the same function, but we have the same stuff used. And if they change on short notice something, that's going to be an issue which finally leads to a change. And to overcome that, we said they have to rely on the same database. To do so, one-to-one alignment, or the one-to-one relation was introduced. So we have a strict coupling between 3D model, drawing, and the parts. There are no metadata, there are no numbers, no naming, nothing which is different. So unfortunately, that's not state-of-the-art in the platform. But we made it tight and couple it now. So whenever somebody changes something on either side of the ball game, you have that information available. Also, we said we want a digital mock-up of everything and not just copy parts and change them a little bit and then reuse them. If needed, we do drawings, but not anymore. We want our guys in the shop floor to look at the 3D models, especially when doing small numbers of train. It's much more efficient if you not have weeks, hours, or even years engineering spending on doing some drawing, that finally somebody can assemble something. If you have a whole digital mock-up, you can look at that and reuse it at every point of time. And this is what we do through 3D experience. We have the mechanical guys, which use their mechanical parts. We have the electrical guys, which use out of the same database their electrical parts. And we have these joint parts, which are like a lamp belt or a sensor for an air condition or whatever, available on both systems. And those two things we synchronize through PLM, so in ERP we only see one truth. That's what we want. And how we achieve that, you have two anchor points. One is on the mechanical side, the functional scope, where we design a braking system or air condition, integrate the door, integrate the passenger information system, all that kind of thing we anchor in a functional scope which identifies its function of the system. On the electrical side, we do have as well a functional scope. We ignore that one when getting the bill of material synchronized to the PLM system, where we anchor that at the installation spots. Because at the end of the day, whenever I screw something into the ceiling, it's still mounted in the ceiling. No matter what source it has, it will end in the ceiling. Otherwise, I have a problem when delivering the train. And by having these two anchor points, we finally said we have to align them, and that's what we did. Is we rearranged the BOM we have from CATIA, so it fits into the location purposes or into the location spots. And this we do by just linking, drag and drop these structures, assemblies into a second resolution which we look at. And on this resolution, actually, we will then compare the BOMs and the parts, numbers, quantities between the mechanical, electrical world. Identify where we use more or less or even different things than what it's supposed to be. And by identifying those things, we can clean them up before transferring the structure out of this installation-oriented focus into the ERP. And this helps us to reduce faults, be much faster, and enable a simple transfer. Looking at it in a written way, as you see behind me, we have the chance that the mechanics are first or the electrics. Normally, not both departments are aligned. That's, I think, daily behavior on any engineering departments which do have both. When the electrical are first, which they presumably are, at least they state that they do, they release certain stuff or would at least trigger that you can already purchase your lamp belt. You not have to wait till the integration on the mechanical side is done properly. And by having that sequentially done, you have to wait until both informations are aligned. In our case, we could use the left hand, or from your side, the right hand side BOM, order these three parts, electrical parts complete, and the first, which is an electrical mechanical part as well. Now, when getting the mechanical BOM finished, we resolve that, find them, and will reduce then the BOM quantities on one side according to a special algorithm, so we not duplicate our quantities in the ERP. But we reuse what we already had, and we're able to generate a much earlier trigger to the ERP for purchasing those things. And at the end of the day, this helps us to align those two disciplines and even benefit on our hard schedule. Such a project is difficult to run and the challenge. So we have a few things in place which help us to make it successful. I have here 3 more slides. One is we tried to split the project in different stages. We didn't want to disappear for 2-3 years, enable a lot of functionality, and then go out and see if it works or where it might not work after extensive tests. So we decided we will enable engineering, as whenever we get a new project awarded, engineering has to start first on the mechanical as well as on the electrical sides to get the things going, copy what is already available, and design new what has to be created new. The second phase will be when engineering is able to work, that we enable the production. So we have to get all this information into our ERP. We have to get the right information and access to our workforce in the shop floor, that they are able to weld, mount, glue, everything what is provided. And then on the last step, we also want to enable the service and a few other things around. And this we achieved in about 8 months. We started in November with implementing first sprints and went live with pilot projects in May. So quite an ambitious roadmap. I think about 20 guys from Technia Transcat have at some time been working for us. They did a marvelous job to keep this commitments and define or implement what we defined to them. And now we are able to validate this functionality with 2 pilot projects. We found out that the whole complete requirements we had are already fulfilled to about 60% in this initial phase, and the next 12 months will hopefully slow down a little bit the space we are busy in testing, but we'll ramp the whole thing up so we have the full project out. We use in parallel SmartTeam, CATIA V5 for all our existing projects. So we are in the situation that we have 2 technologies, 2 ways to work in place in parallel. But this allows us to really validate the new stuff, tune it, iterate it, so it's ripe and mature when putting that aligned. We go Agile project way, Scrum, some of you know. I think it's the only way to succeed. It's good if you see after 4 weeks what your specification cost and you're able to correct to get it where you want it. Also, it helps the guys which learning about all the new functionality to follow that step by step. And I think this is a very good maturing approach. We also applied it to our users in the pilot projects. We not train once everything. We train them about a day on CATIA and about a day at Innovia, respectively the PLM platform. And then we do in weekly or monthly sessions in about 1-2 hour blocks upgrade or enhancement training so that they're really able to use this functionality in a daily scope. We do have different levels of coordination for the project. We are lucky enough to have a direct contact to DASSO as well as to Technia Transcat management. So when some escalations are there, we can handle them. And we have the team itself divided in different groups, so not everybody talks about everything. 7,000 employees, a lot of different opinions. That doesn't work if you get them all on one table. So we make sure when on the important things are talked about, we are not more than 10 internally, which still causes some headaches from time to time, but I think it's worth. And here, a look at the pilot project. This MGB shunting locomotive, it's out of the system. As I said, it's loading fast. We are able to edit, use our structure, and are looking forward to enable that as well for the production. That's, to end, how Stadler looked like a few years ago. That's how it's an actual picture. We are even thinking about enlarging and building another building, so it will look different the next year. And PLM itself, we didn't try to revolutionize everything or change everything, but we have the impression that the best workforce which we have should have a good tool that enables them to use it daily. And we are sure with TVC, TIFF, but 3D experience as an underlying frame, we will do here a successful help to enable also in the future some nice trains and transport passengers. Thank you very much.
Thank you, Roland. That was a 3D experience from a customer perspective. Very interesting, I must say. And please, if you have any questions, you know how to do it. You can also raise your hands. Yes. We have a microphone here, maybe. Or I repeat the question. Please tell us.
Yes. No. As we not have all the users in place, the majority of our users are still running the old platforms with the existing projects. So we have 2 pilot projects and about 50 users on the new platform.
Could you repeat the questions, please?
Oh, sorry. Yeah, it was about if we did a big bang change of the system at one time, or how that reaction then was of the users. And we really try to do that in a smaller step, as I said, with pilot projects. So only some users get exposed to the new system, and they should then start talking internally about all the benefits of the system. So you have a crowd which finally is willing to really change and use that. And that was a very good approach to do so. As I think just from educating, getting the know-how spread, you cannot do that in a big bang.
We also have another question up here. Here, right? Yeah.
Did I understand correctly that you still use a smart team from Dassault's competitor? Did you not consider to change over to Dassault's platform for 100%?
I mean, we use Smart Team right now as a PDM system, a legacy system, which we will replace. And we therefore think have the right decision by staying here.
Okay, a more broad question for me then. We were listening to Honeywell Turbo this morning, and they talked about the key to make the employers really understand and to use the system and also to use them smart. You touched upon this a little bit. Could you elaborate a little bit about that? What's your view on the keys here?
The key is that you bring an engineer as close as possible into the system. This is by individualizing his structural view. So you saw it before on the electrical and mechanical side. We really allow the mechanical guy to work in his way, in his mindset, in his thinking by being on this functional scope. And this helps him that he is, first of all, not has to change everything, but still feels safe in orienting and collecting the data. And the other discipline, the electrical guys, are also in their scope, and then actually the system does the transition or the language exchange practically between the disciplines. And I think that helps tremendously to get the people into the system. Besides, as we change a lot on the systems and also on the processes, you have to make sure that everybody has a few buy-ins. Even you have maybe one or two obstacles which are not perfect with the first shot, that's acceptable, but they have to have at least 3, 4 things which they like every morning or every day or every afternoon whenever they use the system, and this also keeps them in the system. And we have an open discussion on what should be improved, and this gives a lot of requests and also work then to the colleagues here in Sweden as well as in Germany. Yeah.
Okay, Jonas is laughing and he has the microphone, yeah?
Maybe, yeah, thanks for helping us to improve, Roland. You're doing a great job there. Just a comment on your remark there, obviously, Smart Team is previous generation Dassault platform. So we are migrating from an early generation Dassault to a newer. But it's a great kind of example of where we take you from a bit older technology to the fresh technology. Yeah. So it's not a competing system, Smart Team.
Yes, question over there as well.
Thank you. What process is in place to get feedback from the depots, from the workshops? So do you design to better maintain?
The feedback from the workflow is that they want the data really live and not as printed out drawings. And therefore, we are still enabling, and I looked with interest at Helium yesterday, that they get the data, first of all, as 3D models, but also then with all metadata they need, and not the functionality as rich as an engineer has them to reduce to that amount what they need.
You do get feedback from the field, and you will change the design.
I mean, we have weekly meetings with some of our key users on the CATIA side as well as on the PLM side, and from the shop floor purchasing, even down to logistics, and seeing that to arrange it and get them the best view out of it. So it's a little bit like Christmas for those guys right now.
All right.
Great. Great interest, Roland, and I'm sure you will have some more questions in the coffee break, maybe.
I'm around.
Yeah, you're around.
To approach me, thanks.
Okay, thank you very much.
Welcome.
It's very interesting. And